Okay, hello everyone, and today we will talk about two new features in NetXMS. One is asset management functionality, and another is monitoring devices collecting data and collecting data via Modbus. Some small introduction to asset management. So usually with NetXMS, you do monitoring of your devices, servers, sensors, etc. And usually NetXMS operates with them as with some logical entity. So you have a node, an object, which has IP address, and NetXMS server communicates with the node and collects the data. But it is actually some physical devices, and sometimes devices get replaced. And usually when, for example, you replace a faulty network switch, and you will not create a new node object in NetXMS because you will also collect the data, all the settings, etc. You just put a new switch in place, configure the same IP address, and pretty much everything continues. But you may want to keep track of what happens with your actual hardware. And so we introduced asset management functionality to the NetXMS. With asset management, you can have configurable schema where you define what attributes you want for your assets, and you can connect actual physical assets with the logical node objects within NetXMS. And you can change this connection. So you can track that that particular logical node was in fact three different physical devices, for example, in its lifetime. So that's the main purpose of asset management. It's to track physical assets and link them to logical monitored devices within NetXMS. And Tanya will do a short demonstration how asset management can be configured and used and how it looks like. So,
yeah.
Tanya.
Let me share my screen. Okay. Yeah, so I hope you can see it now. Okay, so first of all, let's check the schema. So in the configuration, we have asset management schema, where we define all the fields, field types, how does asset entry will look like. Let's create new element. It will be free form description. It will have type string. It won't have any system type. System type is used for automatic matching asset with a node, or for auto fill some of fields. So yes, in our case, we'll just create some simple description, free form text. And we'll say that it's mandatory. So yeah, as you can see, we have name for each attribute that is an XSL format name. We have display name that will be shown to user. We have data type. We have options for each attribute. If it's mandatory, unique, if it should be hidden, I will show later where exactly. If it should be auto-filled, auto-filling is done by the autofill script that can be configured, its range and its system type. So this is how look schema. Now let's create the asset. Assets are created in asset view. Here you can see that I have some assets that are linked. As you can see, they were pre-created, and you see there is a warning that description that is mandatory is not set for this asset. So if I will add here description, no warnings will be seen here. But those were already created by myself. And if we'll check its statuses, they are already linked to some nodes. Let's create new asset. So new device game, we are creating asset. It has name and ls as every other object in our object tree. Okay, and as you can see, we have all the fields that can be set here. And with asterisk, we can see that fields with asterisk are mandatory fields. So in our case, it's only description. I will leave most of them empty, but we will say that location is storage for now. Okay. Now I have created new asset. So when asset is created and all required or optional fields are filled, the next step that can be done is manually linking the asset with the node that we want to link. It's first option. Second option is to link asset automatically. So for example, you have created new assets with new routers, but they are not yet in the network. If you will enter for this asset, check. I need overview. Let's enter serial number of the asset. And in our case, it's really important that serial number, the field that we call serial, is also has system type serial, because we check all the fields that has we check the field that has this system type, and we'll match using this system type node to the asset. So now if I will make configuration poll on this node, we can see that on configuration poll we're checking if we have applicable assets for this node, and if we have, we link them. So we can see that we have found that new test asset is applicable for this node, because we checked the serial number and it had the same serial number as this node. So we know that we should link them, and it's written that we link them. Then we have updated some properties. So model, vendor, IP address, and the string name have been updated. If we will check in the schema for this ones, so IP address has system type IP address. MAC address is another system type that we're using for matching. If it doesn't have serial, we will match by MAC address. But if node has serial, we won't go to MAC address matching. But it's not out of field. model is another field that is auto-filled. Serial is the field by which we have matched this node, and vendor is also auto-filled. But as we saw, string name also was filled with the name of the object. And if we will check here, we can see that it had after-fill script. So this field will be automatically filled and or updated once the asset is linked to the node. Once we have the source where we can get this information. So now we can see that this node has asset tab, and it has all the information automatically updated or pre-configured that we already entered about this node. And if the hardware will be changed, serial will be changed, and we will make relinking to another asset. So the node will be the same. The data will be the same, available on this node without interruptions, but the assets that represents the hardware itself will be changed. So all the changes in the assets can be found in asset change log. So here you can check that what system have been updated, what user have been entering, and stuff like that. So mainly in like the top level, this is all about the asset configuration. So first you configure the schema, then you configure assets. Even if you already have some configured assets, you can add some fields or delete fields from the schema, and they will be adjusted also in the assets. And also what I wanted to mention is that we have documentation chapter with more details about how to configure all this stuff and what each data type or system type means and how they are updated and how they are connected together. So I think that's all from my side. I can return back Victor. And Victor, we will talk about what was it?
Modbus. It was Modbus.
Yes.
Yeah. So that's another new feature in version 4.4. It's data collection via Modbus TCP. And I do a very quick demonstration how it can be configured and how it actually looks like. So I have this system here, and let's add some devices that has Modbus TCP support. Yeah.
Yeah.
So
now I can see.
Yeah. Here we are. So that's the first device that I will be adding is an actual electricity meter from Siemens that has Modbus TCP capability. I will disable SNMP just for speeding up the configuration post. You see that now we have a new fields. When you create a new node, you have the Modbus TCP port and Modbus unit ID. Let's check. Yeah, so we have our device. In capabilities, we can see that Modbus TCP is supported, and also it was able to get some device information via Modbus. So we have the vendor, we have the product code, and we have the product version. Not every Modbus capable device will return this. Only devices that support read device identification command will provide this information. And if we go to the properties, we now have a new page under communication, which is in Modbus. And basically, you can change the port, you can change the unit ID, and you can set a proxy if it's not reachable directly. And the usual proxying scheme with zone proxy will work as well. So if a device is in a remote zone, zone proxy will act as a Modbus proxy as well. Now, let's go to the data collection and set up some data via Modbus. Unfortunately, within Modbus protocol, we don't have any means to walk through or to get a list of supported metrics, etc. So we have to rely on the manual for the specific device. So for that particular device, I have documentation with all the Modbus registers documented. So, for example, let's configure the current on first this pin. So current L1. In our documentation, you can find the description of the Modbus, and the most important is syntax for Modbus metrics. Basically, it goes as optional unit ID. If it's not specified, then the unit ID in communication properties for the node will be used. Then register type, again optional. If you do not specify it, it will be holding register, but you can specify that it's input register, discrete input, or coil. And then a mandatory register address followed by optional conversion. So if we go to our documentation, we see that it's register 13 and it's a floating point number. So it took actually 2 registers. So let's configure the metric. So we create a new metric. We select Modbus as an origin, and the metric itself we will, for clarity, put that it will be holding register address 13. Then we put a type symbol, and we put the conversion that it's float, so it's floating point number. And we specify data type, of course, as a float, and it's amperes. And so we have it created, and it gets its value. So now we have our value from the device, from via Modbus. Let's try to configure something else. So, for example, we have this active tariff, which is register 211, and it's unsigned long, which means like a 4 bytes integer unsigned. So let's create a new metric. Again, Modbus. It was 211. So we just put an address here because holding register is a default, and we specify the conversion unsigned integer 32 bits. And we get 0 from the device. There are multiple possible conversions. In the documentation, in the conversion section, you see all the possible conversions for receiving values. Let's add another device. Again, let's disable SNMP. So this is a Teltonica modem which has Modbus TCP enabled. We can see in capabilities that it supports Modbus TCP, but this device does not respond to the device identification command, so we don't have any information about hardware. However, we still can read registers and we can do some data collection. And if we take a look at the documentation for Teltonika, they have strings, which is interesting. So for example, if I want to read the system hostname, it is register number 7, and it is string of 16 registers, which means 32 bytes maximum. So let's configure string DCI weekly new metric Modbus. So it will be register 7, and its a conversion is string, and then I should specify the length of the string, and NetXMS will automatically calculate the number of registers to read. The data type is string. No. And here we are. We just read this value via Modbus, which is a string value. This is it. Really simple, quite easy to use in our opinion, and yeah.
I have questions. Yeah. So if it's 16, why it was 16 and then 32?
Yeah. So if we take a look at the documentation, it says number of registers. So each Modbus register is a 2 bytes. So that means that the string will be 32 bytes max. And in our conversions, we use bytes. So for the string, you specify how many characters will be there. And also another nice option that as a second option for string conversion, you can specify the code page. So for example, if you know that it's an UTF-8 string, then you can specify UTF-8, or if it's CP12, whatever, you can specify. For a floating point, you can specify byte order, 4 versions, and for double values, 8-byte floating point numbers, you can specify if it's a big endian or little endian. Yeah, so pretty much that's it about Modbus. Works nice.
Okay. Any other questions?
Okay. So those actually are our 2 topics for today. It was pretty quick today, and of course for everybody not seeing it, was not able to connect, we will publish it on YouTube soon.
It's 2 main features that were introduced in 4.4, so they are available starting from 4.4. Yeah.
Okay, so let's wrap it up then, and thank you.
Thank you.
Thank you.
Bye.
Bye.